I will announce it on the blackboard. After the class, I will announce it. Okay, no problem. Okay, so yeah. Okay, let me review the material. So we are already done, almost done. So just let me review the material. Okay, so I'm opening the, so this page. Okay, let me open a file. Let me open a file. Okay, so if you look at the screen, So during the quiz and during, okay, let me make it bigger. Okay, look at here. So this is the machine code template. So this page I will share with you. I think I already shared with you with the blackboard. And if you not and also during the quiz, and also during the measure time or during the exam time, I will also give this one. Look at here. Here move operation, you can see register or memory to or from register. So what is the template for what? So look at it. These two actually you may not see sometimes at these two. These two you may not get sometimes some book, but it needs like this kind of instruction. For example, if we have an instruction like move comma al. Okay, so so move square bracket 2010 comma al. Okay, so that means it actually register to memory. Okay, register or memory from register. Okay, so this kind of thing, register or memory from register. So this format. Okay, now look at here. So memory is given directly. The memory offset address is given directly. So we know the format. This one definitely it is in this format. Okay, in this format. So 1000010, and D is, what will be the D? Is it from register or to register? Is it from register or to register? Because the register is the second operand, right? Here register is this one. So from register. So it is from register, then it will be D is 0, right? And what will be the W? Is it a 8-bit operation or 16-bit operation? 8-bit operation, right? So W is 0 also. Yeah. So then it will be, yeah, first byte is done. Then what will be the mode? So definitely as it involves the memory, so memory mode. Register mode only when both operand are registered. Okay, or there is no memory involved. So it is a memory mode with zero displacement follows. So 00. Okay, 00. And what is the REG? REG for AL, if you look at here, look at the table, it will be 000. Okay, now it's about the a direct address. If it is direct address is given, okay, if we go down, direct address is given, okay, look at here. If it is direct address is given, look at here. So if so this is mod 00, right, mod 00, and if it is direct address is given, you can see the direct address. If it is direct address is given, so register or memory, that one is 110. Okay, so that means it will be 110. Okay, so that means this register amount, it will be 110. Okay, again I am writing because as I move. So this kind of example we didn't discuss, so that's why try to understand this one. For example, 2010, this is a memory offset address, so memory write operation. So the register data, register content, it will be written on the memory, right? So definitely it is this format. So what will be the binary code for machine language? 1000010, and then D is from, as it is from register, so D is 0, and W is also 0 as it is a 8-bit operation. Okay, so this is for 1 byte. And then what about the mod? Mod is 000 because as it is a memory mode with with 0 displacement follows. And then REG. REG for AL is 000. Okay, 000. And then register or memory with this mod 00. So here register or memory, so memory is this one actually, register or memory field is this one. As it is a direct address is given, so it is 110. And now look at here, the address, offset address 2010. So address low. So address low, it will be 10 here, 10H here, and then address high, it will be 20H. But if it is address is not directly given, we don't have to use this one. Like we didn't use it before. Like for this case, like for example, move. If you can remember, we use this. We use this kind of thing. Move SI square bracket SI comma AL, for example. So here, so okay, which one you didn't get it? All right, let me discuss. So address low, okay, address low, look at here, address is directly given. So address is, this is 2010 is the offset address of the memory location, right? So offset, so address is given. So 20 and 10. So 10 is the address low and 20 is the address high. So this is the offset address. 2010 is the offset address of the memory location, right? Yeah. So this 10 is the address low and 20 is the address high. So that means what will be the in the hexadecimal? So we can say that 1000, it means 8, and then again 1000, it is 8. So first byte is 88, and then second byte is 00 000 here. So that means 0, and then 0110, so 6, and then 10 and 20. 20H. So together. So that means how many memory location it needs? 1, 2, 3, 4. So 4 memory location it will take. So is it clear? This one is clear? Yes. Yes, okay, okay, fine. So I think we discussed many example, but this kind of example where actually one of the operand is direct address is given, something like that. This kind of example we didn't discuss, so it will be like that. So if but if here, look at here, for this case, move square bracket is like this is also same kind of operation, but here it is not direct address given. So here actually indirect addressing. So then actually address low and address high, these two field we do not need. We didn't use it also before. Okay. So sometimes, like we may need, sometimes we don't. Yeah. So this is about the move operation. Then add, you can see the add. Okay. Another thing is, look at here, register or memory to segment register. In some book you can see it is SR given, so segment register, or some book you can see REG. That means this is also for segment register. So I think SR is good appropriate because register field is 3 bit, but SR is 2 bit. So okay, don't worry. So it is SR segment register. Like if we use the data segment register, so SR is 1 1, something like that. If you can remember, we use it. Okay, so SR or REG, it doesn't matter. And addition, you can see addition, increment, then subtraction, decrement, then input instruction, output instruction, unconditional jump instruction, JMP. And conditional jump instruction, look at here, what are the common conditional jump instruction we use? One, we use jump equal or jump zero, jump not equal, jump not zero, or jump if carry, jump if no carry. So look at here, this one actually in the last class we use it. So I couldn't remember what was the, first byte it was. It is actually, you can see 7-2, but I wrote actually, just guessing. I wrote 7-3. Actually, it is 7-2. You can correct it on you. If you note down the lecture, you can correct it 7-2. Doesn't matter. And then this displacement, we have to calculate the displacement, how many memory location forward or backward it jumps. Okay, and this page is this is for REG field, and this is for mod. Okay, they may be 0 0 0 1 1 0 1 1, and mod, and also if it is 1 1 mod, what will be the register or oblique memory? And if it is mod 0 0, what will be the register oblique memory? Or if it is mod 1 1 0 1, then what is the this, so on. And what about the segment register? You can see segment register. If it is data segment register, it is 1 1, or if it is it's so on. So this page actually, so I think probably, I'm just overviewing it, because this one actually you may get it in the quiz and also during the measure, and also, yeah, it's like that. So so machine code is okay for you? All of you are okay with this machine code? It is okay. Okay, so I will upload a homework. I will upload a homework. Practice the homework also. I will upload a homework. Practice the homework before the quiz, so that everything will be clear. Okay, so I will upload a homework as well. So based on machine code, you will have a homework, you will have a quiz, and you will get it also in Measure 2. Okay, machine code. So this is, practice it. If you do not practice it, you cannot manage the time during the exam, because exam time is very limited. It's not like you are doing a quiz for 1 hour. It may be like the whole measure exam within 1 hour, for example. So you have to practice it, so that you cannot waste the time. Okay, more practice. I will upload a homework. Practice it and try to understand it. Don't blindly copy something from other. Actually, try to understand it, and then you will get it It's not a very, I mean, good hard things or any hard topics. Okay, so this is all about this machine code. Hopefully all of you get it. Okay, let me review the other things. The topic. So I am opening the another file, just it taking time. So yeah, hold on please. Okay, what are the, I mean, yeah, what sort of question we may have from arithmetic and logic instruction? Let me go page by page. So yeah, this one is like a, yeah, so I mean subtraction, addition, already you know it, logic instruction. Okay, so okay, so this one is actually is a very basic. Actually, I think it's a very basic thing. Shift. Yeah, look at this example actually. So like shift left, shift right. Okay, uh, let me check. Okay, so here actually we have we don't have many topics here. It's a very short chapter. So yeah. So what actually you can review here, like shift, rotate left. Okay, so here actually you can see these are the yeah, just see the example of, like if we have a 8-bit register, if it is a rotate left L comma 3, what will be the change? So rotate left, rotate right, just understand the I mean operation, basic operation, and shift right, shift left. Yeah, okay, because shift right and rotate right, they are not same. So just only see the difference. And rotate right and shift left, so rotate left and shift left, they are not same. Okay, so what is the difference between these things? So just try to get the get, get the example. Here it is, for example, here we can see it is a 16-bit. Okay, rotate left, it is 16-bit register. So instead of 16-bit, try to understand the 8-bit of you will get the 16-bit also as well. And shift left and shift right. So these are the 4 examples. So that means basically what can we write here? We can say that difference between, okay, so basically I mean just these two things. Okay, if a difference between rotate left and shift left, and difference between rotate right and shift right, what are the difference between them? Just you look at the example. So example, for example, here it is yeah, here it is like uh, ROR, ROL, AL, comma 2, or and S H L L, comma 2, or it is the same thing within a specific example, for example. So this is about the difference between these two instructions. And here maybe same thing like ROR with example, or just only the mnemonic, or only the opcode. ROR AL, comma 2, and S H R AL, comma 2. Okay, so I mean with example, or just like or like ROR, and what is the difference between ROR and shift left, and ROL and SHL. Okay, so this chapter is actually basically just only the few things here, only just one topic here. Okay. So is it clear? This chapter is basically we don't have many things. We just we can see that shift left, shift right, rotate left, and rotate right. Okay, so this is one thing. And another thing is just one more. I think this one is also, you can see it here. If we have a like logical operation, if move AL comma this one, what will be the AL content? If it is and logical or logical XOR and not. So this is about the logical instruction. And this one is not fully same but similar, because here move AL comma 10101010, but here it is 01010101. So it is similar. So looking this example, try to get this one. Okay, so they are similar. So these two topics, one is about the logical instruction, only logic and shift instruction. Yes, logic, shift, and rotate instruction. So okay, so that means what are the things I am writing here? So this page, okay, page number what is the page number here? 7. So page number 7. Yeah, and what I said at the last time. And this one is shift left and shift left and shift right. So this is page number 10. Page number 10. And here it is rotation left and rotation right. This is page number 14. Okay, so this 3 pages is enough. So here actually we don't have many topics here. Is it clear for this chapter? Yeah, and then and then control flow instruction, you already get it in the during the quiz, you know, control flow instruction. So we can see after the arithmetic or logic operation what is the what are the changes in the flag bits. We do understand now what are the changes in the flag bits, and also yeah, some difference between some yeah, string instruction. Okay, let me open that file. Okay, so in a control flow instruction we can see that yeah, there are some special, yeah, one thing is we what is the difference between sub instruction and compare instruction. Okay, difference between sub and compare instruction. And so one of the example is here, what are the changes in the flag bits. Okay, look at here, compare this one here. So if you look at here, okay, so let me review about the flag. So and this one and the quiz one. Okay, look at here, -103. So compare instruction is this, it is done in the same way as subtraction, but the result is not saved anywhere. But sub instruction, I mean subtraction operation, I mean during the sub instruction, the result saved in the first operand, right? For example, if we write sub al comma 07, so al content -07, this is the subtraction, and then result will be saved in the first operand. So first operand is al, so al, yeah, saved in al, yeah, you're right. So but here actually here during the compare operation, no, it doesn't say, I mean result is not saved anywhere. Okay, now I mean about the flag bits, how actually they are changed. Let me review it again. -103 and 27. So it's basically -103 minus 27 it will perform. So subtraction. So -103 is what? In a binary format 8-bit, it is this one, -103. First of all, get the 103 and make the twice complement. You will get this one. Okay, and then 27. What is 27? This one. Okay, and then we will do the minus subtraction operation, minus. So minus is, so you know already how to do the subtraction. So the result, look at here, the result MSB bit is 0. So MSB bit is 0. Okay, so that means, I mean we don't have any. So first of all, look at here, this first nibble, it is 1001 and it is 1011. So definitely 1011 is bigger than 1001. So definitely we need a borrow. We need a borrowing from the higher neighbor to the lower neighbor. That's why auxiliary flag is 1. Okay, and the result is not 0. So 0 flag is 0. So, and then what about the sign flag? Sign flag is the MSB bit. As it is 0, so it is 0. What about the carry flag? Look at here, carry flag, because we don't have any final borrowing in the MSB bit in here. This one as so there is no final borrowing here happened here. So this one we don't need any borrowing happen here. So that's why carry flag is 0. Okay, or you can think about, look at the here 1001 100. So this one is looking there now, it one is bigger than 001 1011. So definitely there will be no final borrowing. So definitely carry flag is 0. Okay, and what about the parity flag? Look at here, number of 1 2 3 4 5 6. So even parity. So for even parity, parity flag is 1. Now only the tricky part is overflow flag. Okay, so I give you a tricks. Actually, if we have a negative number involved, so this is not an issue actually. Negative number involved. So for if we have a negative number, if we have a okay, if it is a negative number, and if we so for the negative number, MSB bit is for the sign. Okay, MSB bit is for sign. So this is for sign. Okay, now you have to look at the borrow in happened here. I mean, okay, let me erase it. So look at here. Here, we have a borrowing happened in this bit. We have a, if we have a borrowing happen in this bit from in bit number 6 from bit number 7. If it is happen, if it does happen, so then actually this is the sign that okay, auxiliary flag will be 1 or other. So this is, I think this one is good than other thing. So if there is a borrow in happen from I mean bit number 7 to bit number 6. I mean not the MSB bit, next to the MSB bit. If there is a borrowing happen, so then actually auxiliary flag will be 1. So and then actually what does it mean? It means that the result is not sufficient. The 8-bit is not enough for the result. You can check it here. Look at here. So the result is now this one. And what is, look at here, MSB bit is 0. That means it is a positive number. And what is the magnitude of this number? If we convert it to decimal, it is 126. Now look at here. So minus 1073 minus 103 minus 27. It is not plus 126. It is actually minus 130. Minus 130. It actually, the result is minus 130. Okay, so that means this minus 130 is not enough for 8-bit. So it needs more than 8-bit actually. That's the maybe, yeah. That's why it is called overflow flag. Again, I am saying, if again, let me erase it again. So for carry flag, again, what is the difference between carry flag and auxiliary? For carry flag, if there is a borrow in happen in the MSB bit, then carry flag is set. Okay, but for auxiliary carry flag, if there is a borrow in happen here in the bit number 6 next to the MSB bit, this number. Okay, this here. If there is a borrowing happen here, then auxiliary flag is 1. Is it clear? Sorry, overflow flag is 1. Is it clear? Is it okay? Okay, now about let us see the example, but we do not have the borrowing. Yes, we have a borrowing. Look at here. So yeah, if you look at here, so yeah, if you do the, I mean, subtract the, if you perform the subtraction, you will see that we need a borrowing happen here. So yeah, from here, so this we take a borrow from here. So if we take a borrow from here, it becomes 0, it becomes 1 0. Okay, and then we take a borrow. Yeah, so if do the all the things, then you will see we have a borrowing happen here. That's why. Okay, let me discuss the example in the quiz. What was called, so CMP, it was CMP minus 50 minus 20, minus 50 comma, sorry, minus 50 comma 20. Yes, 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 it is, it is. Okay, so let me discuss this one. Okay, compare minus 20, minus 50 minus 20. So minus 50 is actually, so minus 50 is, so it becomes 1 1 0 0. So first of all, get the 50 and then get the twice complement. 1 1 0 0 1 1 1 0. Okay, this is minus 50, and then minus, what is the plus 20? Plus 20 is 0 0 0 1, and then 0 1 0 0. Okay, now let us perform the operation. So 0 minus 0 is 0, 1 minus 0 is 1, 1 minus 1 is 0, and 1 1 minus 0 is 1. Okay, and then 0, here it is 0, 0 minus 1, so we need a borrow. Yeah, get the twice complement 50. Yes, twice complement of 50 is this one, this one. Okay, now look at here. So 0, yeah, yeah, so 0 minus 1, we cannot get the 0 minus, so we need a borrow. So borrow from here, but here it is 0, so that means we need a borrow from here. So from, we need a borrow from here, it becomes, so if we take a borrow from here, it becomes 0 and it becomes 1 0, and then if we take a 1 0 means 2, if we take a borrow from here, it becomes 1 and it becomes 1 0. All right, so now 1 0 minus 1, so 1 0 means 2, 1 0 minus 1 is 1, and then here is, it is 1, 1 minus 0 is 1, and here 0 minus 0 is 0, and 1 minus 0 is 1. So look at here, we do not have final borrow, I mean we do not have a borrowing in the MSB bit, and also we do not have a borrowing in the bit number 6 next to the MSB bit. So that means we have a carry flag 0 and we have auxiliary flag 0. Is that okay? I think, yeah, Abdul Hadi, you are correct. Abdul Hadi, you are correct. So yeah, that's why I increase you, Abdul Hadi, and yeah, Mokbil, and also Hamud. Yeah. So yeah, let me finish. So yeah, the three of you correct. If anybody of you are correct, just let me know. I will check your answer. Okay, let me finish it. Okay, okay. So carry flag is 0. Why carry flag is 0? There is no borrowing happen in the MSBB. Okay, and then what? And also there is no borrowing happen in the next to the MSBB bit number 6. This one here. We take a borrow from here, but there is no borrowing happen here from the MSBB. So that's why overflow flag is 0 and carry flag is 0. And What about the auxiliary flag? Look at here, first nibble. This one is bigger than this one. So there is no borrowing happen from the higher nibble. So definitely auxiliary flag is 0. What about the parity flag? Number of 1, 1, 2, 3, 4, 5. So even odd parity. So it is 0. Okay. And what about the sign flag? Look at the sign flag at MSB bit is 1. Result of the MSB bit of the result is 1. So that means it is 1. And what about the 0 flag? There is, the result is not 0, so it is 0. So this is the result actually. So is it clear? If anybody of you, yeah, you are correct, you can raise your issue, then I will increase your grade in the last quiz. So yeah, so is it hopefully clear, right? What is when the overflow flag? Definitely overflow flag, the concept of overflow flag is coming for negative number, like here negative number. But now when it will be 1 and when it will be 0, it will be 1 if we have a borrowing happen in the next to the MSB, and carry flag, it will be on the MSB. Actually, I was reading many references to get the clear-cut answer. Now it is, I am confident that this is the best way to realize it. Okay, so hopefully it is okay, right? And other thing you may check it. Other thing is you can check it that if like this example, what is given in the lecture file. So if the result, you can see that carry overflow flag will be 1 if the result is actually wrong result. You are like here -103 and -27, it becomes like +126. So this is not the result. That means this 8-bit is not enough here. That's why overflow flag is set. But here actually our result is this one. So look at here, what is the result? So as it is 1, that means it is a negative number. So now yeah, get the 2's complement. Get the first complement and take the yeah, and also subtract 1, then you will get the magnitude, and it will be -70. So that means this result is the accurate result. So that means this 8-bit is enough for -70. So overflow flag is 0 actually. Or we can check the next to the MSB. Both way it is okay. All right, guys, it is clear. Okay, so what about the other guys? Is it okay? Yeah. So this page actually this is about the flag bits during the compare operation or subtraction, whatever it is. There is a change in the flag bits. We are now familiar with it. Okay, and so okay, and then about the there are some yeah, you already get some example, yeah, some question pattern in the quiz. Hopefully it is clear. Hopefully it is clear. So one thing is actually difference between last page. Yeah, macro and procedure. Okay, so what is macro and procedure? Okay, with example actually try to get it. What is the difference between macro and procedure? Okay, so then it is okay, this chapter is done. Okay, so yeah, so define it and try to get it, and with the example maybe you can try to get it. What is the difference between macro and procedure? All right, here like a macro is defined in this way and procedure is defined in this way. Okay. Yeah, and what is macro and what is procedure, it is written here. Okay, so that's all for this chapter also. Yeah, so any question do you have here? Okay, so okay, so you see you on the next week. Okay, so see you on the next week. I will upload a homework based on machine code. Practice this one and get prepared for the quiz and measure too. Okay, all the best. Okay, thank you.